Brothers and sisters, welcome this evening to St. Anne Catholic Church. My name is Father Tom Lawrence, and I'm glad to have Brother Guy with us to talk about things well beyond my ability, and mostly like most of ours. This, of course, is available to us here after about 10 years, I think, since the last time by the King Institute for Faith and Culture. And so I welcome Martin up to share more.
It is a delight to be back here with the King Institute for Faith and Culture. My name is Martin Dotterweich, and I direct the King Institute at King University here in Bristol. The last time we were in this space was indeed for Brother Guy. Some years ago, we also hosted Dr. Robert George from Princeton in this building downstairs a few years ago. So I'm very grateful to St. Anne, to the congregation, to Rosie, and to Father Tom for their help in making this possible. I'm also grateful to say that we're going to have a reception afterwards, so please do linger out in the hall afterwards. We'll be able to have some time to chat, and you can have a chance to come and speak to Brother Guy a bit during that. I do want to mention our final event for the year, and if you don't have one of our brochures, we have a few of them outside. On April the 7th, our final speaker for this year is Gretchen Heisinger. Gretchen runs a podcast from Microsoft Research, and she is somebody who has thought a long time about faith and technology. Tonight we talk about faith and science, but we'll move to faith and technology with Gretchen. She's particularly interested in the question of AI. She just finished a PhD, and the title of the PhD was Righteous AI. So she is somebody who has spent a great deal of time on a subject that is of great interest to all of us, whether we know it or not. She'll be at First Baptist Church on Monday, April the 7th, in the evening at 7 p.m. So please join us for that as well if you're able to. And watch our Facebook site for next year's programming, which will be starting to come out pretty soon. I'm going to ask one of our students from King to introduce Brother Guy. This is Christian Jones. Give Christian a big hand.
Thank you, guys. It's an honor to be up here. I wanted to introduce Brother Guy because I'm one of the, I think I've done astronomy research at King long enough to say that I am an astronomer. I would like to say that. So I do research with planets that orbit other stars. I take astrophotography pictures that are really beautiful. At least I think so. Some people might find them ugly, but I think they're great. I find Brother Guy to be super interesting because of his writings and because of how he can combine science and faith at the same time in a very compelling manner. So I would like to introduce him. So he was born in Detroit, Michigan, and his academic journey led him to MIT. I said earlier that he was wearing the ring from MIT, which he is in fact wearing the ring. And that's where he earned both his bachelor's and master's degrees in earth and planetary sciences, which he'll perhaps tell you a little bit about. He furthered his studies with a PhD in planetary science from the University of Arizona, and his early career included postdoctoral research and teaching positions at the Harvard College Observatory and at MIT. And in a remarkable turn, too, he joined the U.S. Peace Corps in 1983, and he was teaching physics and astronomy in Kenya for 2 years. Something that he told us yesterday is that when he went to Kenya, he took a small telescope. And if you know, when you do astronomy and you get a new telescope, it tends to rain and you can't use it. And so we have plans to open our observatory tomorrow at 8 p.m. And naturally, since he came, it was raining this morning. And the weather tomorrow is cloudy for the 2 hours that we'll have the observatory open. But hopefully the clouds will be, broken apart enough that you can see through them to the planets and we can have something to show off. So in 1989, Brother Guy entered the Society of Jesus, and that's where he took his vows as a Jesuit brother in 1991. And since his assignment to the Vatican Observatory in 1993, at some point he served as the curator of Vatican Meteorite Collection. I think it's someone else now, as you said earlier. And you run you are the president of the Meteoritical Society? Yes, I got it right. Excellent. And so his contributions to planetary science were honored at the International Astronomical Union 2000, where an asteroid was actually named after him. Asteroid 4597, Consolmagno after him. So it's not too often that you get something in space named after you. Everybody wants something named in space after them, and he's actually done it. He's also a prolific author. He co-authored one of my favorite books, Turn Left at Orion. I've used it to figure out where things are in the sky at different times of the year, which is excellent. And I know a lot of other amateur astronomers use this book to figure out where things are. And his writings don't end there either. He's also authored Brother Astronomer, Adventures of a Vatican Scientist. And one that I haven't read yet, but I heard about in the past few weeks, is Would You Baptize an Extraterrestrial, which he co-authored. Notably, too, in 2014, he received the Carl Sagan Medal from the American Astronomical Society for an outstanding communication by an active planetary scientist to the general public. So what he'll be presenting today, I suppose, is an example of what brought him to that medal. And I think they misspelled your name, too, whenever they presented that medal as well. But I find a lot of inspiration in all the things that he does, so I just wanted to introduce him to you guys today, so I appreciate it. Please give him a hand of applause.
Thank you very much, everybody, for coming. It's a delight to be back here again. This is a wonderful, wonderful place. I've titled this talk, A Jesuit's Guide to the Stars. And that's because I've got a book with that title. Sadly, it's the only copy I have. I'm not selling them out back. But the talk that I want to give is based on what's in the book. And I should mention how the book came to be. The fellow who had edited the book, Would You Baptize an Extraterrestrial, enjoyed the experience so much, he said, I've got a title for you if you can write the book. So the book is, I had to fit whatever it was, A Jesuit's Guide to the Stars. Well, I'm a Jesuit. Some of you may know what the Jesuits are or who the Jesuits are, others not so familiar with them. We are a group of men in a religious order affiliated to part of the Roman Catholic Church. The most famous Jesuit out there right now, besides me, is Pope Francis. I understand you also had Greg Boyle here recently, who's another Jesuit. Jesuits come in priests and brothers. I'm a brother. Greg was a priest. And the order was founded in the 1500s by a fellow who was originally named Inigo, but as he experienced a religious conversion, he took the name of a patristic saint, Ignatius, and is known as Ignatius of Loyola. He wrote essentially an autobiography by dictating it to a scribe who then wrote it in the third person. And right at the beginning of the autobiography, we read, the greatest consolation that he received was from gazing at the sky and stars, and this he did often and for quite a long time. Now, he did not want the order to be the Ignatians. He insisted it was the Society of Jesus. And as the Society of Jesus, we're dedicated to become close to Jesus. Jesus as God's incarnation within this physical universe. The first Jesuits were a group of men who met each other at the University of Paris. Scholarship was what brought them together. It was an essential part of what formed them as a society. This unity of hearts and minds came from being students together. It was at the highest university level. That was what was then considered one of the great universities in the world. You had to study not only, theology and philosophy. Before they allowed you to study that, you studied the quadrivium, the mathematics, music, geometry, astronomy. Notice that astronomy was part of every person's studies in those days. Well, the medieval universities are very different now because what you went on to was to get a doctorate in philosophy, and I've got my doctorate in planetary science. Of course, it is a doctorate of philosophy in planetary science. And the robes that you wear at your graduation are still the medieval robes. Our universities, King University, is a direct descendant of that tradition. Now, there are lots of things about Ignatian spirituality that makes it, I could tell the famous stories of the Jesuit and the Franciscan who are praying together, and the Jesuit pulls out a big cigar and lights up, and the Franciscan says, "My advisor said you shouldn't smoke while you pray." And the Jesuit says, "Yes, but my advisor says it's great to pray while you smoke." There is this reputation of being maybe worldly, maybe in the world, maybe certainly someone who's a part of it. But there actually is a very serious side to Jesuit spirituality, and it's the way we run retreats using our minds and our imaginations and our heart. And at the heart of it is something called the spiritual exercises, and at the heart of the spiritual exercises is something called the principle and foundation. And they're short. I'll read them to you. Number one, we are created to praise, reverence, and serve God. Number two, the things of this world have been created to help us accomplish this calling. Number three, therefore, we are to only use those things that lead us to the goal, being indifferent to the things that may lead us away from the goal. You don't reject them, you're just indifferent to them. Number four, we are not to desire things like health or riches or honor or longevity of life, but rather only desire that which helps us become what God created us to be. And that all sounds marvelously pious, and it's a wonderful thing to say. But notice what you find repeated over and over again. Created things. We are created. We are things. The things of the world have been created. Created things lead us to God. Created things that don't worry about them. The spirituality of the Jesuits is all about our place in creation, why we are created, why the world is created, how we relate to creation, and in Jesus incarnate in this creation. This leads to the famous mantra of, find God in all things. Being close to this created world is a way of being close to the Creator. Since the beginning of time, God has revealed himself in the things that have been created. And the Protestants in this room probably know where I'm quoting that from. For the Catholics, it's the letters of Paul to the Romans, first chapter. And that means that created things are important to a Jesuit. What is more created thing than the universe itself? What is more apt for a Jesuit to do than to become part of the physical universe? And in fact, if you think about it, science is a very natural thing for a Jesuit to do. In particular, science as an astronomer. What's more things in the universe itself? But it's an interesting thing about science. Science is this rational, logical way of looking at the universe. Absolutely true. But if you studied logic, you know that every kind of logic begins with an assumption, with an axiom. You don't find God at the end of this logical sequence. God is the axiom that you start with at the beginning. And if you assume that there is a God, and if you assume that it's the Christian God who created the universe, who did it, first thing being light so that everybody can see what he's doing, did it as logically as day follows night, was there before the beginning, already there, then you realize that there are certain axioms that follow from that assumption. First of all, that the universe is actually real. I'm not just dreaming that it exists. Second, that there are no nature gods making the crops grow or lightning strike. And if there are no nature gods, then why do the crops grow? Why does nature strike? This gives you the room to ask, what are the laws of nature? Because you should ask, who's the first person to think that nature had laws? This comes from our faith. It comes from Genesis 1. And that's why you find the physical sciences studied by the people of the book, the Jews, the Christians, the Muslims. The third thing, and this is sometimes the hardest to believe, is that the universe is good. Every step along the way, God says this is good. It means that wallowing in this physical universe is not wallowing in sin. It is rather embracing something that God created to lead us to Him. Chocolate, some people might say, is a temptation to lead you to acne and overweight. But I say chocolate is a foretaste of heaven and should be treated at least as a sacramental. You might ask, as a Jesuit's guide to it, how did I wind up being a Jesuit and an astronomer? I was a Sputnik kid. I grew up born in 1952, which meant that I was in kindergarten when Sputnik went around the world. I was finishing high school when the Apollo 11 landing occurred. Every little boy in those days was going to be a scientist, and that's certainly how they trained me, until I found out that the Jesuits had the best high school in Detroit. I wanted to go to the best. So I went there, and then I found out the smartest kids did Latin and Greek. I wanted to be one of the smart kids. As a result, by the time I had finished high school, I had no idea what I wanted to do. I went to Boston College originally to be a history major because I figured history covers everything. But my best friend was at MIT, and I discovered that MIT had the world's largest collection of science fiction books. So in order to read science fiction, I convinced them that I was going to be a science journalist, talked myself into the Department of Earth and Planetary Science. Planet sounds like astronomy. I had no idea what an astronomer does for a living, so I figured I'd become one and find out. And when they accepted me, which if you don't believe in miracles, there's one. When they accepted me, I discovered I was in the geology department. Really? Geology? If I had known, I would never have chosen. It turned out to be the easiest department to get into. Also, it turns out that there are rocks that fall from the sky, from outer space, called meteorites. You can hold, like a relic, a piece of outer space in your hand. And that was just so amazing that became the cornerstone of my research. I stayed there so long, I wound up doing a master's degree, also read a lot of science fiction. Went off to the University of Arizona that had just started a brand new department of planetary sciences, the first in the world. I was one of the 10 first students. 9 of us guys, 1 woman. Only one of them had a vowel at the end of his name, namely me. So, if I'm the minority, then you realize what the world was like back then. And I continued doing this planetary science until I was 30 years old. After my degree from Arizona, I went back to Boston. I said, I never want to live in Arizona. It's too hot, it's too dry, full of old people. I live there now. I think it's a great place. But I went off to Boston, to make my fortune. I got a postdoctoral degree, position at Harvard, another postdoctoral position at MIT. If you're in academia, 5 years as a postdoc means couldn't get a job. And what's more, I would lie in bed at night wondering, why am I doing all this effort trying to understand the moons of Jupiter when there's people starving in the world? Because I'd gone to that Jesuit high school, and I'd had that conscience crammed into me somehow. And I had no answer. I had no future in the field. I was just doing the job because it was the only job I knew how to do. I was 30 years old, incredibly old, and thought, this is my last chance to have an adventure. So I quit science. I threw away all my notes. I figured I'm never going to go back. I joined the U.S. Peace Corps. I thought they were going to send me someplace, that was really exciting and I could help the poor and whatever. The difficulty was that as soon as I got there, I realized I'm a nerd. I like reading adventure stories. I don't actually want to be in one. I was incredibly homesick. Homesick like you wouldn't believe. Homesick to the point where I was physically ill. There was a time when most of the members of our 80 of us who were training together were off doing various training sites. And I was so physically ill that the trainer sent me back to the training camp. I was there by myself. And I came to realize I had made a terrible mistake. Peace Corps said, if you want to go home, we'll send you home immediately, no questions asked. So I said, okay, time to go home. But if I'm going to go home tomorrow, you say, as soon as they say you want to go home, you put you on the next flight home, that's not a problem. But if I'm going home tomorrow, tonight will be my last chance to ever see the Southern Cross. Here we are in Kenya, right on the equator. I take out my H.A. Ray book, the Stars, the one written by the guy who wrote Curious George. I look up, I'd had this book since I was a kid, and he says, at 4 a.m. in December in Kenya, you can see the Southern Cross rising. So I wake myself up at 4 a.m. I go outside, and there it is, the Southern Cross and Alpha and Beta Centauri, these stars that I'd learned about since I was an earthly kid. And I turned around to go back to my room to pack to go. When I turned around to the north, on the horizon was the Big Dipper. And you could arc from the handle of the Big Dipper to Arcturus and spike onto Spica. And all of the stars of spring were overhead because it was 4 a.m. There's Leo the lion right overhead, very appropriate for Africa. The winter stars, Orion, all of those are setting. The summer stars are rising up. 16 of the 20 brightest stars in the sky were visible at that moment. And these are the stars that my dad had taught me when I was a kid. These are the stars that I loved looking at all my life. And I said, how can I be homesick? I am home. Any place where I can see stars, that's where I belong. Well, I thought I was going to be teaching at a little school. I decided, here I am, I'm staying here. And I was there for 2 years. I originally thought I was going to be teaching in a high school up country someplace, helping the poor. But they took a look at my credentials and said, no, we're going to put you at the university teaching astrophysics to graduate students. Well, there was a logic. The guys I was teaching all had jobs waiting for them at the Kenya Science Teachers College. They would teach the teachers who would they be there for the, not just 2 years like me, but for their life. So there was a logic. But I still wanted to be, I had all these 80 friends of mine who were in the real Peace Corps. Every weekend I'd get on a little jitney cab, a matatu, and go up, and I'd bring my little telescope with me. I ended the drought in many places in Kenya by setting up the telescope. But on occasion it was clear, and people, I don't know if you've ever looked at the sky in a little telescope. Have you seen, how many people have ever seen the moon through a small telescope or a pair of binoculars? Yeah. How many of you have ever seen the rings of Saturn? 3. How many of you have seen the rings of Saturn and not gone, oh, wow? Because that's what you do when you see the rings of Saturn. I don't care how many times you've seen them. And it doesn't matter whether you're an American with a PhD or a rural Kenyan farmer, you're still going to go, oh, wow. You're still going to ask, what are those things? Who am I and how do I fit into that? That's why you do astronomy. Those are questions that human beings ask. My clever cat, never wanted to look through a telescope. That's why we do astronomy, because it feeds our soul. We don't live by bread alone. I read that someplace. It was so exciting to me. I also discovered I really love teaching university physics. I got a teaching job at Lafayette College. But it wasn't enough. When I was in the Peace Corps, I was standing for something more than just myself. So after 4 years, I thought I could do this teaching at a Jesuit college, at a Jesuit university. I'd thought about being a Jesuit. I figured I'm too much of a nerd to be much of a good priest. I don't know if you've ever had the difficulty of having a priest in your community who is also an engineer. They are incredibly meticulous about following the rubrics, you know. If you drop a semicolon, then the Mass won't compile. I didn't want to be one of those. But Jesuits have brothers, and brothers are for people with special skills, and being an astronomer is a special skill. The Jesuits accepted me. I took vows in 1991. I spent a couple of years studying philosophy, and then I was ready. All right, which of the 22 odd schools that the Jesuits run, which one are you going to send me to? 3 vows you take as a Jesuit brother. Poverty, I don't own anything, but then I'd been a grad student, I was used to that. Chastity, I don't date, but then I'd been a grad student, I was used to that. Obedience, I was not used to. Under obedience, they ordered me, not to a school where I was wanting to teach, but under obedience, I had to go to Rome, live in the Pope's palace, eat that terrible Italian food, look at that boring scenery, and oh yeah, there was a collection of 1,000 meteorites. Remember meteorites? Remember how I love meteorites? Yeah. For my sins, in 2015, the Pope made me the director of the Vatican Observatory. Every Christmas, there is an audience of all of the heads of all of the different departments in the Vatican, both the Holy See and the city-state, and I'm in the room. My assigned seat is in the back of the room, but I'm in the room. And as I said, the Pope is a Jesuit. The Pope knows me, which is kind of scary, but kind of wonderful. We have a summer school every 2 years. We bring in students from around the world, 25 really bright students. And the summer school in 2018 was held in June. We had an audience of the 25 students and the instructors. And as the Pope walked in to address the students, he sees me and he says, "Guy, I understand your father has just died, and I want you to know I'm praying for him." Wow. Wow. So, that's also part of being a Jesuit astronomer. The idea of Jesuits doing science goes back almost to the Jesuits, and the role of the Jesuits working with the Vatican goes back almost to the origin of the Jesuits. There was this thing called the Council of Trent, you may have heard of. Happened in the 1560s. It actually happened it happened soon after Copernicus wrote his book, suggesting that the sun was the center of the universe. And do you know what the Council of Trent said about that heretical idea? Absolutely nothing. They could care less about it. What they did say was that, you know, the calendar is messed up. There isn't exactly 365 days in the year. The difference is so small that it runs to less than 1 day a century, but it's been 15 centuries. It's time we fixed it. And our way of figuring out when Easter is has to be fixed because it depends on, you know, where the moon is and whether it's a Sunday or not. But we've got missionaries from the Philippines to South America. What if it's Sunday in one part of the world and Saturday in a different part of the world? How do we figure this out? They hired a bunch of people, including a Jesuit named Christopher Clavius. If you remember the movie 2001, it was Crater Clavius. And they worked out the reform of the calendar, the first time that the Gregorian calendar we're talking about, the one we use to this day, the first time that the Jesuits in particular were hired by the Holy See to work out an astronomical problem. Between then and the early 1600s, there was the whole Galileo affair, and I don't want to get into that, except everything you know about Galileo is probably wrong. The truth doesn't make the church look any better. But what the Galileo trial was all about had nothing to do with astronomy. had nothing to do with his science. You don't believe me? You can actually find the transcript of the trial translated into English in a book by a guy named Finocchiaro called The Galileo Affair. Read it for yourself. Read the things that people were saying for him and against him, and you realize the story is way more complicated. 20 years after the Galileo trial, a Jesuit priest named Riccioli, Jean-Baptiste Riccioli, did a very thick scientific treatise on the science known by that time and came up with good scientific reasons why the Copernican system, the idea of the sun being in the center, just didn't match the observations, that it was another 100 years before people could figure out what we were doing wrong, that it made it look like the Earth was standing still. But he also created the first modern map of the moon with the nomenclature we use to this day, including naming a crater for Clavius, naming a crater for himself, naming craters for his friends, but naming the most prominent crater on the moon, Crater Copernicus, because he respected Copernicus as a good Catholic and as a great astronomer. Nothing unusual about that. Jesuits were also missionaries, but they were also overeducated. And so as missionaries, they had been trained, maybe by Clavius, maybe by the people who trained Clavius, to be astronomers. Simply by sheer numbers, they make up an impressive fraction of the astronomy and geophysics done from the 16th century through the 21st century. Indeed, if you think about what a scientist actually does, it's sorting and gathering data. You know, before there were spreadsheet programs, there were spreadsheets. Or maybe you'd write things on little 3x5 cards and sort and file. What do you call sorting and filing? It's clerical work. Why do they call it clerical? Because it was originally done by clerics. If you go and look at just about any volume of scientific papers from the 17th century into the middle of the 19th century, who are the people doing science? Well, the people doing the science are either wealthy noblemen, maybe medical doctors, or clergymen, the Reverend so-and-so, because who else has the education and the free time to do the science? Of the many Jesuit scientists who I could name during that period, there's one in particular I want to talk about. Maybe the greatest astronomer you've never heard of, unless you subscribe to Sky and Telescope, because there was an article about him 2 months ago. His name was Angelo Secchi. He was born in 1818, so 200 years later, in 2018, we wrote a couple of books about him, and he had a celebration of his life and his work. He was a remarkable guy. He built the first mechanical device that used electricity and magnets and things to record automatically weather data. What's the temperature? What's the wind direction? He set up a system of weather reporting, using the telegraph so that people from the west would tell you what kind of weather they were having, knowing that that's the weather that's going to be coming east in a few hours, maybe a day. He provided practical applications of science to civic life, from timekeeping. He was one of the guys involved in putting all of Italy on standard time. He worked out the proper drainage of cities so you didn't get diseases. He worked out standards for reinforcing buildings against earthquakes. He set up the first magnetic observatory in Italy, which is to measure the magnetic field and how it fluctuates with time, and just recording that. One day he went out on the one boat in the Vatican Navy and invented a gizmo that is now called the Secchi disk, which is used to measure the clarity of water. You drop it down until you can't see the disk anymore, see how many feet of rope it takes, and that tells you how clear the water is. Still used to this day. He set up lighthouses, he installed sundials, he surveyed the Appian Way. He was a key player in reforming the metric system. But here's the real thing he did. If you've ever been to Rome, there's a church halfway between the Pantheon and the Trevi Fountain called the Church of St. Ignatius, a Jesuit church, near the Jesuit school where Secchi taught. And it's an interesting church because they wanted it to be one of these big Baroque churches with a big dome and all the frills. They ran out of money. The roof is flat. If you go in there today, you can see the roof, and it looks like a dome because it's painted in perspective by one of those Jesuit brothers who has the skill. But the cool thing is, the roof is flat. There were 4 pillars designed to hold the weight of a dome that was never built. Secchi says, this is where I'm going to put my telescopes. And he put telescopes on 2 of the 4 domes. One of them was a big honking telescope that he used to observe the surface of Mars. Before then, you observed Mars to measure its position in the sky so you could calculate its orbit to 1 more decimal place. For a long time, astronomy was considered a branch of mathematics. But Secchi looks at it and says, what are those markings I'm looking at? It looks almost like there are continents and channels running between them. And he's describing things that you can see to this day. The things he called channels, he used the Italian word canali, which was then misinterpreted a generation later for optical illusions as if Martians were building canals. He did something even more amazing. He took a prism and put it in front of his telescope lens so that every star he looked at became a spectrum, a rainbow. But within that spectrum, you can see whether there are different colors that are missing that look like spectral lines. And that tells you what chemicals are present. And the brightness of one color over another tells you the temperature of the star. As a result of that, he looked at 5,000 stars and sorted them into half a dozen classes. This is the beginning, the absolute beginning of what became the Hertzsprung-Russell diagram, which became the tool that astronomers use. It basically invented astrophysics. He not only made an observation nobody had ever made before, he was the first person to ask the question, what are the stars made of? Rather than where are they and how can we tell better time with them. He did this all during the turbulent historical times of Italy. He was kicked out of the country in 1848 when there was one revolution. He nearly lost his job in 1870 when the anti-clerical Italian government confiscated the Roman college where he taught and the observatory where he worked. But he was so famous that they let him keep his job. He died at the age of 59. Having done more than any other 3 people I can think of in that era. That's Jesuit astronomy. Looking at the universe not because it's a practical thing to do, but to ask the questions, what is that? What does that mean to me? Astronomy is the way we do that. It's not the only way we can do that. At the same time that Secchi was doing astronomy, in England and Ireland, there was a young man named George Manley Hopkins who was writing poetry. One of the things I have in this book is an interview with a fellow named David Levy. Those of you of a certain age may remember Comet Shoemaker-Levy, the one that hit Jupiter 30 years ago. David Levy is a comet hunter, an amateur. He does it for the love of it. His degrees are actually in English literature, and he has written extensively on George Manley Hopkins, the poet, and his poetry about stars. He's looked into Hopkins' notes, and he says, this guy knew what he didn't just go out, oh, wow, look at the stars. He knew the stars. He knew what he was looking at. Hopkins was a Jesuit poet. Famous for a number, God's Grandeur is maybe his most famous poet. I want to read one of his poems, a very early one. It's before he had the really odd sprung rhythm. And it's actually out of a play that he was writing. So it's in the words of a character in a play. I am like a slip of comet, scarce worth discovery, in some corner seen bridging the slender difference of two stars, come out of space or suddenly engendered by heady elements no man knows. But when she sights the sun, she grows and sizes and spins her skirts out, while her central star shakes its cocooning mists, and so she comes to fields of light. Millions of traveling rays pierce her. She hangs upon the flame-cased sun and sucks the light as full as Gideon's fleece. But then her tether calls her, she falls off, and as she dwindles, shreds her smock of gold amidst the sintering planets, till she comes to single Saturn, last and solitary, and then goes out into the cavernous dark. So I go out. My little sweet is done. I have drawn heat from this contagious sun. To not ungentle death, now forth I run. That also is a Jesuit's Guide to the Stars. And incidentally, that opening line, bridging the slender difference between two stars, allowed David Levy to figure out which comet he was talking about, because there was a comet about that time that passed between 2/3 magnitude stars. There is this idea among a lot of people that the church and science are opposed, inevitably opposed, irreparably opposed. And you have to ask yourself where that idea comes from. With Jesuits doing astronomy around the world, with Jesuit missionaries being sometimes the only educated scientist in countries, and then being able to write their reports back to the Jesuits back in Rome, where they were all assembled. Why do people say that the church is anti-science? When science was invented at the universities, and the universities were invented by the church. Why do the people say the church is anti-science when even our poetry is filled with a scientific understanding of the universe? Well, there's actually an answer to that question. Dates from the end of the 19th century. It's a grand Victorian idea. Like most Victorian ideas, it kind of makes you embarrassed to look at it now. How many people here, when you were growing up, learned that Christopher Columbus proved the world was round? If you are of a certain age, you heard that. If you're young, you probably never heard that, or at least you heard people talking about it, making fun of it. But it was certainly a staple of our growth, if you've got gray hair like me. And when you think of it, number one, of course, everybody knew the world was round, but besides that, how did Christopher Columbus prove anything? He never even made it around the world. What a stupid thing to say. Even the people who then say, oh, and they thought that the earth was the center of the universe. If the earth is the center of the universe, it would have to be a ball. So even that statement contradicts the idea that everybody thought the world was flat, because obviously everybody didn't think the world was flat. That idea, and a lot of other incredibly stupid ideas about faith and science, comes from a book by Andrew Dixon White, the founder of Cornell, called A History of the Warfare of Science with Theology in Christendom. And the main thrust of the book was that there's a branch of Christendom called the Catholics who are anti-science, and we've got to keep them out of America. People like Consolmagno with names that end in vowels are going to ruin the place. Underneath all of this, where did the church oppose science in their mind? Well, by the end of the 19th century, modern science, besides giving us, steam engines and electricity, which is technology, not science, never mind. Modern science has explained the human race through the theory of evolution, which is, a perfectly innocent description, completely consistent with Genesis. God makes life out of dust. That's what evolution is saying. But then there were people who had turned it into a social program. They took that phrase, survival of the fittest, and said, well, if I'm rich and you're poor, it's because I'm more fit than you. It's only natural. There's no point in me wasting my money trying to make you guys any better. Not only that, I can improve this place by keeping the inferior people out, people with vowels at the end of their name. And you can tell they're inferior because they're mad at me when I draw this to its most logical conclusion, which is eugenics. Let's breed successful people, breed superior people. How will you know if a person is superior? Oddly enough, they're people who look like me. If you think superior people look like you, maybe that's where the "you" in eugenics came from. No, it isn't. The church opposed eugenics because it was immoral. And, eugenics met its logical conclusion in the death camps of Nazi Germany. But in the 1890s, in the 1910s, you had Alexander Graham Bell writing an article in favor of eugenics in National Geographic. You had Oliver Wendell Holmes using that, justifying the sterilization of, quote, unfit people. In a decision of the Supreme Court that was never overturned, and the only person who voted against it was the one Catholic on the court. If the church was opposed to that, obviously they're opposed to modern science. Obviously we have to make sure that, well, there was a bad reaction in the church, which was to say, the heck with you people, we don't need you anymore. But Pope Leo XIII had a different idea. He decided that what the Vatican needed was its own national scientific institution to show the world that the church supported science. And what better institution than an astronomical one in honor of Angelo Secchi, who had made a name for himself in the 19th century as an astronomer. The fact that it was Secchi's assistant who came to the Pope and said, wouldn't this be a good idea? There was also a kind of a subtle political side to this. At this time, Garibaldi and his armies had conquered all of Rome except for the little area around the walled area around the Vatican. The Pope insisted that the Vatican was still independent. The Italians said, no, you're not. We're just being nice and not putting you in prison. By having a national observatory, you would be recognized as a nation by all the other nations who would trade national observatory reports to get your national observatory report. And in particular, the French, who didn't like the Italian government anyway, the French had come up with the idea of finally making a map of the stars that was really accurate by photographing the entire sky. Much too big a job for any one observatory, so they invited the national observatories from around Europe and a few in South Africa and South America. The Vatican is invited as one of the national observatories. The telescope that the Vatican bought was identical to all the telescopes the French used, and they sort of manufactured for everybody, except the English who wanted their own. The very first plate was taken by the Vatican's telescope in the region of the sky that was assigned to the Vatican. After you photograph the plate and you've got all the stars on the plate, then you need somebody to measure the position of those stars. You need a computer, or better, a team of computers, because in those days, computers were women. You remember the movie about that, Hidden Figures. The women that the Vatican enlisted were the nuns of the Sisters of the Child Mary. They went to the head of the order, who then gave the work to the novices. The 4 women spent 10 years measuring 500,000 stars. And they now have asteroids named for them as well. It was a way of showing that the church was not anti-science. The director of the observatory eventually was a Jesuit priest, originally from Austria, and then he'd come to America and was actually running the observatory at Georgetown University when he went back to Rome. After he died, about the same year, Italy finally agreed to recognize the Vatican as a nation. Do we still need a Vatican observatory? The Pope then, Pius XI, said, yeah, this is still a good idea. He invited the Jesuits to send a new crew of astronomers to his summer home in Castel Gandolfo that he had just gotten back from the Italian government. They moved in, set up a laboratory there that measured the spectra of pure metals, so you could compare the metal spectra to the spectra of stars. And that's where astronomy was done until the 1980s, and of course still being done in many other things except astronomy, but light pollution eventually meant that you couldn't see the stars very clearly from Rome anymore. So in the 1980s, the Vatican also set up an outfit in Tucson, Arizona, which is why I'm there half the year. And we used the telescopes of the University of Arizona. And then in 1990, a fellow at the university who had a new way of making a telescope mirror made one of these mirrors, came to George Coyne, the director of the observatory, said, hey, if you build a telescope around the mirror, we'll share it. So we now have our own telescope on top of Mount Graham with a mirror made by Roger Angel. Yep, Pope has a telescope with a mirror made by an angel. And today, the Vatican Observatory is going strong. There's a dozen astronomers working there. We come from 6 different nations, 4 different continents, speaking, I think, 9 languages. Maybe that's just Father Gabor himself, from the Czech Republic. One of the things that we get to do as astronomers at the Vatican, we've all got doctorates from the regular universities, the same as anybody else. Big universities you've heard of, like Oxford. Small universities that are really good in what they do, like University of Central Florida, which is actually a really big university. They don't have a big basketball team, so you may not have heard of them. When I arrived there 30-odd years ago, the boss said to me, here's your job, do good science. We're not assigned science to do, it's up to us to figure out what is good science to us. We're not given a timeline that you have to have this done or you're not going to get tenure. Back in the days when I was an astronomer being supported by NASA, I did the work that NASA said they'd pay for, not necessarily the work I wanted to do. And I'd better have results after 3 years or my grant wasn't going to be renewed. I can do things like measuring the physical properties of meteorites, a project that took 8 years before we had enough data to start publishing, and data that is now used by everybody, to the point that one of our members was invited by NASA to come and make the measurements on the samples that NASA brought back from asteroid Bennu. Because we don't compete with other astronomers for the same funding, and because we have this view of more than just the astronomy that, I'm trained to do, we wind up being very often called upon to work in international astronomical societies. You heard I'm the current president of the Meteoritical Society. At one time, I was the chair of the Division for Planetary Sciences of the American Astronomical Society. Father Chris Corbally, an English scientist with us, has been very active in the International Astronomical Union. He was the one who wrote the definition of a planet that reclassified Pluto. And, incidentally, if you think that poor Pluto was demoted, you're implying that somehow being a planet is better than being a dwarf planet or an asteroid. If that's what you think, you're guilty of planetism. Heaven forbid you wouldn't want to do that. What is distinctive, then, about Jesuit science? Doing science as a Jesuit comes with these advantages. You'll find a number of Jesuit scientists, Jesuit astronomers, who would not have been able to go to college except that the Jesuits paid for them to go to university. McElwaney was a poor farm kid in Ohio and was allowed to first study, got the first PhD in seismology from Berkeley. That would never have happened. The guy I mentioned from who went in our group now, who went to Oxford, grew up as a poor kid in New Orleans, the son of Honduran immigrants. Being a Jesuit opens up these doors. On the other hand, being a Jesuit means they also want you to study theology and philosophy, which, while it's a good thing, it means you're about 40 before you have a chance to set up your lab. Being a Jesuit means that you have the opportunity to travel around the world. I mentioned the missionaries. You know, to be able to go to a place like South America in the 1700s would be like being able to go to the moon today. What an advantage. On the other hand, they could also order you to come back from there and, oh, we're going to make you the head of some school back in Spain, which happened to one of the guys. Being a Jesuit means that doors are opened. Being a Jesuit means that people will hate you because you're a Jesuit. One of the reasons nobody hears of Angelo Secchi is that the English scientists were so jealous of what he did that they refused to allow his books to be translated into English. It is a different kind of experience being a Jesuit and an astronomer. But finally, I just want to end with 3 points of what makes a Jesuit's view of the sky different from anyone else's. The first is why we do it. We're doing it to find God in all things. We're not doing it to become famous, to get our names in the New York Times, though that's happened to me. We're doing it not for the glory of Guy, but for the glory of God. We're doing it for the joy we experience when we discover something new, because joy is evidence of God's presence. It's in the way we do it, not just with the intellect, but also the heart, writing poetry as well as writing scientific theses. And to recognize that the sky is beautiful. And after a day of staring at a computer, I'll walk outside and look at Jupiter and say, those papers that I was writing about the moons of Jupiter, that's the thing I'm talking about, that very thing, that light in the sky. It reminds me how a theologian must feel when they stop writing theology and they go into the chapel and pray. And it's about what we do with what we've done and what we've learned. We write it up. The missionaries writing back to their friends in Rome. The poet who writes the poem. The scientist who teaches it in a class. Or me writing a book like this. That's who we are. That's what Jesuit science is. And one of the most welcome aspects of it is to see how many of my fellow scientists take heart at what we do, not just because they can use the data I come up with. When I talk about the role of God in my life, the most common thing I hear from my fellow scientists who are believers is, yeah, I thought I was the only one. I'm not telling them anything new, but I'm reassuring them, you're not the only one. Weirdest thing when I became a Jesuit, I came out of the closet as a believer, was how many of my friends also were believers, also were churchgoers, every church you could imagine. Some you might not. But even for those who don't claim to be believers, we remind them of why we're doing the science, not to show up the people at Arizona State, but to find the truth and to find the joy in the truth. And that's this Jesuit's Guide to the Stars. Thank you so much for coming.
We don't want to wait too long for the reception, but we do have time for a few questions before we adjourn into the hall.
Don't be shy.
Bradbury versus Roddenberry.
What? I didn't catch.
Bradbury versus Roddenberry.
Ah, Bradbury versus Roddenberry. I am of an age where I'm a real snob about my science fiction. I hate being in the room with the television showing science fiction, even good stuff, because to me it's too private. And I hate people calling it sci-fi. Sci-fi is that cheap stuff like you'd see on TV. SF is what I read. I'm a total snob, and I'm ridiculous. I realize that. That's who I am, though. So Bradbury, not Roddenberry.
This has nothing to do with science. I'm a native of Easton, Pennsylvania. I'd like to know how the heck you ended up at Lafayette College.
Oh, it was a delight, and what a one. Of course, you know our great George Foreman, who was from there, just died on Friday. I was sorry to hear that. When I was in the Peace Corps, I realized after it was done I wanted to teach, and nobody was going to hire me because I looked like 100 other people applying. But I saw 5 schools that had openings in their physics and astronomy department. And I applied to the 5 of them. And I got a telegram from Lafayette College asking if I could call them on Monday morning. I got the telegram Monday afternoon. So I hoped that maybe they'd still be around the next day. And I thought maybe they're going to invite me back to America to interview. So I spent the rest of the day collecting notes from people. What do you want me to bring back from America? I'm going to go there next week. And when I had to find a telephone in the right time, so I walked into the Peace Corps nurse's office. And as soon as I walked in, she goes, A positive, I need your blood. So I traded a pint of blood for the use of her telephone to make a long-distance call to America. I called the chair of the department, and he said, we've decided to hire you. And I'm going, no, you have to interview me first. I've got to go back to America. And he said, no, we saw your background, the Peace Corps thing jumped out. And they were the ones who wanted me. It was a lovely school, and I was so happy there that I could make the choice to be a Jesuit. You should never make these decisions in desolation. You make these decisions when things are going well, and then you can see clearly. And I said, I want this, but more. So, of course, I didn't get it.
I have 2 questions. First one is, what is the most interesting thing you have learned in your astronomical studies? The second is, what is the most interesting unanswered question in astronomy to you?
I'm a planetary scientist, so I'm not gonna touch on dark energy or black holes or things like that. Those are fascinating, but that doesn't affect me directly. The most interesting unanswered question is, how do planets form? And we've got lots of ideas, and we've got lots of theories. 50 years ago, when I was a student, we had a beautifully elegant theory that explained why planetary systems like ours, which was the only one we knew, why planetary systems would have rocky planets that are small, close to the sun, and gas giant planets that are big, far away, and nothing in between. We have now discovered about 8,000 other planetary systems. None of them look like that. And the vast majority of the planets we've discovered are in the size range that we had proved was impossible. So, there's a lot to learn. And there's a lot more going on than we thought. And that's going to keep us busy for the next 100 years easily. For me, the most interesting thing that I was involved in understanding was understanding sort of I do meteorites and asteroids. It was recognizing that asteroids are not big rocks out in space, but they're piles of rubble left over from what might have been rocks earlier that broke up and fell together. And we don't even know how many times this break up and fall together happened, including even an asteroid that I once thought was, a beautiful little moon covered with lavas. We've sent a spacecraft there. No, that's not what it is. Its surface looks like it's been broken up and fallen back together again. So this is a brand new way of thinking about asteroids. And my work was not the key bit, but it was one of the little bits that helped bring out this new picture of it.
Hi. I work in psych, and I deal with a lot of atheists who use science as a basis for their atheism, and I was just curious if you have any thoughts or any scientific defenses for people who want to defend their faith with using their own angle of science that they prefer to use back at them.
Well, I love shocking people. And wearing my MIT ring and a collar, of course, always shocks them. The biggest shock is telling them the truth. There are a lot of ideas of God out there that I don't believe in either. I only believe in one God that's only one more than theirs. We're closer than you think. And the Jesuit theologian Michael Buckley wrote a book about atheism, and he starts out by saying, in order to be an atheist, you have to have a very clear idea of the God it is you don't believe in. Otherwise, how do you know you don't believe? And most of the time, the God they don't believe in, I don't believe in either. We're on the same team. Now, a more sophisticated take, especially you'll find among younger scientists, is that they would say they're agnostic. They don't know. Of course you don't know. None of us know. All of life is making choices based on the inadequate data. Should I have come to this school? Should I have come giving this talk? Should I have given the talk I gave rather than a different talk? I can't go back and do it again. I have to have some faith. But as I think it was Anne Lamott who said, the opposite of faith isn't doubt. The opposite of faith is certainty. It's because we have doubts that we start with faith, that we need faith. But our faith is the assumption we start with. If you assume there is no God, you can come up with a view of the universe. It's actually push it to its extreme. It's not a particularly pleasant view of the universe. If you assume there is a God, it's consistent with everything we can see, but everything takes on a new light. And it answers a lot of the questions that atheism can't answer. You know, one of the things you were thrown at is something called theodicy. If there's a God, a good God, then why is there evil in the world? And I'm not going to give you the answer to that because it's not a simple answer. To quote the movie Time Bandits, has something to do with free will, I think. But the interesting thing is, not believing in God doesn't solve the problem. If there's no God, then why is there good in the world? And that actually has led philosophers like Raisa Maritain to become devout Christians. So I have no problem with people who say they don't believe in God, if in fact the God they don't believe in is the same God I don't believe in. But nonetheless, they believe in truth. They wouldn't fake their data just to get ahead. They believe in goodness. They won't do bad things, nasty things. And most of the people who I know who would call themselves atheists or agnostics, certainly they believe in truth. Certainly they believe in the right thing. I think they believe in the same God I do. They just are afraid to admit it.
As we adjourn, I want to ask if we can let Brother Guy make his way out first to the foodstuffs out that await for us. I also want to mention that something that Christian alluded to earlier is that tomorrow our observatory at King will be open and Brother Guy will be there. We may or may not be able to see the sky, but we'll see tomorrow night. Either way, we'll have some refreshments there, and I hope you can come and spend some more time with Brother Guy there. For now, in a moment, we'll make our way out. But first, please join me in thanking Brother Guy Consolmagno.
Thank you very much.